Exponential functions, horizontal shifts and reflections, and function notation. Something unexpected happens when we perform horizontal transformations on exponential functions. They can always be represented as vertical transformations. Oops, there should be an S there. And or a change to the parameter b, the multiplier. So any horizontal transformation can be represented as a vertical transformation or a change to b in the original function. So for instance, if we take the graph of f of x equals 4 times 2 to the x, so that is this right here, and we move it 3 units to the right, we get g of x here. As you can see, 1, 2, 3. Every point on this graph, f of x, has been moved to the right 3 units to get the graph g of x. So this is a horizontal shift. We also might call it a horizontal translation, either one. And we can write that as g of x is equal to, g of x is equal to 4 times 2 to the x minus 3. However, we could also write it as g of x is equal to, and if you look, we can just think of this in terms of given what we know. So this right here is this point right there, moved to the right 3 units. Since our multiplier is 2, and this is 0, 1 right there, we know that this point has a y value of 1/2, so that point does as well. So we can write g of x as 1/2 times 2 to the x. These two transformations can also be represented in function notation. The first representation, moving f of x to the right 3 units to get g of x, can be represented in the following way. G of x equals f of x minus 3. Now, you might be thinking, wait a second, this is one function equal to another function. But notice, all we've done is if we take our original function here, f of x, and we plug x minus 3 in for x, that's our input, then this up here becomes x minus 3, just as we have right there. And you need to be careful because this may appear to be opposite of what you'd expect. And what I mean by that is that this looks like we're subtracting 3 from x. But be careful, this is our h. And since we have x minus h, that means our h is positive. Our h is a positive 3. We've moved to the right 3 units. The second representation of the transformation is a vertical dilation, or another word for a dilation is either a stretch or a compression. And here, this would be a compression. And I didn't give much room there, so you're going to have to squish it in. Of f of x and can be represented as, and so notice that what we've done is we've taken this 4 that was here, and now our a value is 1/2. And so really what we've done is we've multiplied the entire function f of x by 1/8, because 1/8 times 4 is 1/2. So we can represent g of x as taking the original function f of x, multiplying it by 1/8. And so what happens is that 4 times 1/8 becomes that 1/2. So we're taking the entire function f of x and multiplying by 1/8. In example 2, let me get it so you can, well, you're not going to be able to see all of it either way there. So I'm going to pull myself down just a touch so you can see it. All right. So in example 2, if we take the graph of, again, that same original function f of x and reflect it horizontally across the blank axis, that's the y-axis, the result is g of x. If we want to represent this transformation in terms of x horizontally, so we want to think of this as a transformation in terms of x, then g of x is equal to 4 times 2 to the negative x. And you can try this on Desmos, and you'll see that if you have your original function f of x here, and then you make that x a negative x, then you'll get this function g of x. However, the graph can also be represented as g of x is equal to, well, let's look. Our a value here is 4. And then when we move to the right 1 unit, our a value is 2. Excuse me, our y value is 2. Our y value here is 2, and when we move to the right 1 unit, our y value is 1. So we're dividing by 2, which remember is the same as multiplying by 1/2. So our a value is 4 times 1/2 to the x, which can be seen as a change to the parameter b. So we've just changed from our original function when our original b value was 2. If we reflect our original graph across the y-axis, then we change our parameter b to 1/2. And that's how every horizontal shift and reflection can be represented as either a vertical transformation or a change to the parameter b.